record. If you guys have any questions, if something doesn't make sense, just stop me, please let me know, and we'll definitely go over it again. All right, so we'll do this together. So here's question one. So current starts over here and is going to flow from left to right. So we see it first hits a parallel branch, then it condenses as a series, and then it goes back into a parallel branch. Right. So we need to consolidate these circuits. So what we're going to do is we're going to take our two parallel branches and we're going to consolidate them into one resistor using the parallel method of adding resistors. So 1 over R plus 1 over R. So for the 4 and the 8, we get 1 over R equals 1 over 4 plus 1 over 8. That becomes 3 over 8. And then when you flip it upside down, R is 8 over 3, which is 2.67. Okay. We're going to repeat with the 7, or I'm sorry, the 5 and the 10. It's upside down on my screen. Okay, so with the 5 and the 10, we get 1 over R is 1 over 5 plus 1 over 10. That's 3 over 10. And then when we flip it upside down, R is 10 over 3, which is 3.33. So here's what that gets us. We're going to redraw this, or we can think about redrawing it, and it'll look like this now. Instead of that 4 and 8 resistor, I'm going to replace it with what I wrote in red, and that new value is 2.67. And instead of the 5 and the 10, I'm going to replace that with the one we found out. That's 3.33. So if we look now, all right, we can ignore these two guys, the blue 4 and the blue 8, and the blue 5 and the blue 10. And if we trace through, we go through this first resistor, then this second resistor, and finally this third resistor. And all three of these, red, blue, and this red one, are wired in series. So to find out the series resistance, we just add them together as regular numbers, no fractions. So the overall resistance is going to be 2.67 plus 7 plus 3.33. And when you add them together, you get 13 ohms. Any questions on number 1? All good? Okay. All right, so let's look at question 2. So here we go. Current comes in up top. It goes through this 4 ohm resistor, and then it splits into these 2 parallel branches, and each branch has 2 resistors in it. Okay. So again, the goal is to consolidate. We can't really do anything with this 4 yet, and we can't add the left side of the circuit to the right side yet because we have multiple resistors. So we're actually going to first take a look at the 11 and the 7, and we're going to combine them since they're in series, and we can write 11 and 7 again. That's going to become 18. And the 3 and the 6, they're going to combine, and they'll form 9. So now this parallel portion, instead of being made of 4 resistors, 1, 2, 3, 4, we now just have 2. 1, 2. Now it's just a parallel problem, so we can add 1 over R is 1 over 9 plus 1 over 18. that's 3 over 18, or R is 6, because that's 18 over 3. Oh, there you go. And now, to finish this problem up, I'm actually going to redraw it since I already have a lot of stuff here. We have the 4 resistor at the top, and the original 11, 7, and 3 and 6 have paired all the way down to just one 6 ohm resistor. So we went from this, and now we're here. And then to find out the resistance here, they're in series, so 4 plus 6, that gets us a total resistance of 10 ohms. Are you taking Ellie with you? Okay. All right. Any questions on 2? All right. All right, 3. So 3 is definitively the trickiest problem on here, but we're going to tackle it the same way. All right, so let's look at 3. Whoop, way here. So current comes in, it goes through a resistor, so it has to go through this 10 ohm one. It doesn't have a choice. Then it splits. It could go straight down and back out, or it can continue across the 6. And then here it can split. It can either go down through the 3, or it can keep going. I'm sorry, this is a 2, not a 6. It's backwards on my calendar. So it comes in through here. It can go either through the 8 or the 2. If it goes through the 2, it then can go through the 3 or the 6. So we have lots of different portions here. So we're going to work from the way over here, and we're going to just bring it back in, and we're just slowly going to consolidate every branch that we can. So if we work our way back, the 6 and the 3, here and here, these are wired in parallel. So we're going to first take care of these two using the parallel method. So that's 1 over R is 1 over 3 plus 1 over 6. When you do that, you end up with 3 over 6 equals 1 over R. So R is 6 over 3, or 2 ohms. And here's what that actually kind of does for us. 1 sec. 2. So this is what it was originally, and then by consolidating, we turned this 3 and this 2 into just 1, 2. So we still have the 10, we still have the 8, we still have the same 2 up here, but these two numbers, the 3 and the 6, they combine to form this new 2. So now if we look at this circuit, you go through the 10, and now you have a choice. You can either go through the 8, or you can go through the 2 and the 2. So the 8 and the 2 and the 2 are in parallel, but we can't do it just yet. We first need to take these two numbers, these two 2s, and combine them into one number, which would be 4, because these are in series to each other. And if we do that, we just cross the 2's out, and we imagine we made just one resistor. Oops, sorry, with a value of, there it is, 4. Okay, so again, 10 to the 8, and then we combined these two 2's, they became 4. Now the 4 and the 8 can be taken care of via parallel. So we would get 1 over R is 1 over 4 plus 1 over 8. That's 3 over 8. R is 8 over 3, or 2.67. And now our circuit looks like this. Hey, excuse me. Don't smash Buzz Lightyear into the window, please. He's not going to fly through the glass. Not a good idea. Yeah, we don't want to smash them into the window. So we basically consolidated all the way to that. And now to find out the total resistance, we just add 10 and 2.67. We get 12.67 ohms. That would be the answer to question 3. All right. So that's all 3. Does anybody have any questions on any parts of those 3? Number 3 is definitely tricky to look at, but again, work from the outside in and just start breaking things down, and hopefully it ends up kind of clicking. Anything? Good, 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 good. You guys all doing okay besides physics-wise? Are we okay? We doing all right? Are we bored yet? Yeah,
Yep.
me too. Me too. Oh, goodness. Well, hopefully we get to see each other again in person before the year is over, but who knows? Who knows? One day at a time, one day at a time. All right. Everything else all good? Somebody
It's all good. Just a lot of schoolwork.
Lots of schoolwork.
Yeah.
Hey, it keeps you busy, I guess, a little bit.
Yeah. I don't have anything else to do.
Yeah, I know. It's a bummer.
Yeah.
Yeah, well.
How's
Yeah.
the baby?
She's good. I was right here. If you give me a sec, she just came back. I'll show you her. So give me 1 sec. If you guys want to hang or sign off, that's fine. But I'll give me 1 sec. I'll get my child for you. You shut the door? I lied. She'll be back in like a minute. She's right down the street. So feel free to stay on. I'm gonna